Welcome everybody. Today we explore how to build React applications using clean architecture with MVVM or model view model as a complementary pattern. Before we start, some words about me. So, hi everyone, I'm Marc. I've been working as a software engineer since 2013, and I'm with Space Teams from Hamburg, Germany. At Space Teams, well, we of course have our favorite technologies we like to work with, but we don't set ourselves any boundaries there, so we're basically technology agnostics. And to always stay up to date and, for example, dive into new technologies, we have one dedicated day in the week where we have our so-called space time to do just this. Okay, so here's our agenda for today. So first, we identify some common software development issues, like, for example, tight coupling or scalability challenges. And these problems cost businesses real time and money. But what if there was a proven solution to these problems? And that's where clean architecture comes in. And this is Uncle Bob's proven architectural pattern. Well, it provides our structural foundation, right, with clear separation of concerns. However, clean architecture alone doesn't address all the front-end challenges here. And that's where MVVM becomes essential, because it's kind of the perfect complement for clean architecture here. It enhances the presentation layer, specifically filling that gap, right? But then enough theory, and let's see this working in practice, and that's what we're going to do in step 4, because here we're building a real-to-do application demonstrating this combination. And then finally, we'll see how this combination solves our original problems. And at the end, you'll get a maintainable and testable React application. So, yeah, let's start by understanding the problems we're trying to solve here. So, we've all been there, right? So, a React code base that started simple and clean, but over time became a tangled mess, where making a single change feels like defusing a bomb, right? So, you see, software development faces multi-phased issues that plague projects daily. And these aren't just any theoretical problems here. These are real challenges, right? Costing businesses real money. So whether it's a very large component, for example, with dozens of conditional statements, or components so tightly coupled that changing one breaks 3 others, we basically know the pain, right? So we'll now examine 8 specific issues that could emerge in software projects. But, and here's the good news, we have a proven architectural approach that can help us solve these problems. And this is clean architecture combined with MVVM as a complementary pattern. So first, let's dive into the problems here. So on the slide here, you see 8 problems that plague software applications across different technologies and create real business costs here. And as you can see, these are categorized in 3 different categories here. So first category are structural problems. And here, for example, we have code duplications. And this basically means that you have the same code snippet in different parts of your application, right? And now, if this one code snippet has a bug, this could mean you fix it in one place, but you might forget the other 3 places, right? And this will come back to you later on. And then we could also face tight couplings. And this basically means that your components know too much about each other. And, well, this could mean making a change in one place. This could break 3 other components, right? And we could also face scalability challenges. And this basically means what might work for 10 components could fail like 400 or so, right? So, next category are development issues. Here, for example, we could face testing complexity, right? And this means it could require us mocking half of our application just to test one component. And this is, for example, due to all these tight couplings of our components. We could also face reduced maintainability. And this basically makes every change risky. And this is, like mentioned, due to these other problems, right? So the code duplications, tight couplings, and so on. And we could also face some inconsistencies. So this basically means we have the same functionality implemented differently elsewhere in our application, right? So if you think, for example, about a simple form in one place, you could use a validation library A, right? For a second form, you use a library B, and maybe for a third form, you use your own implementation. So there are some inconsistencies in our code here, and this makes it also hard to maintain our application. And then the third category are business impacts. And here, for example, we could face difficulty in migration. And this could, for example, turn a simple framework upgrade into a, let's say, 6-month rewrite instead of just being a 4-week task or so, because we have to deal with all these code duplications and tight couplings and so on, right? And we're also fixing or seeing some lack of flexibility here, which basically prevents rapid market responses. And this is, well, due to us dealing with all these issues we just talked about, right? Like the tight couplings, testing complexity, and so on. And then we see some cost and time implications. And cost implications could, for example, mean that bug fixing becomes a primary activity in our code base instead of just feature development, right? So clean architecture with MVVM directly addresses each of these problems with proven patterns and clear boundaries. And that's what we're going to implement in our React application later on. So, but just how expensive are these problems? So let's look at the real numbers here. So on the slide here, you see some hard data from Code Census research on 39 commercial code bases, showing what poor code quality actually costs organizations. So for one, it has an impact on development speed. So you see, and features in poor quality code take 124% longer. So this means that a 2-week feature becomes nearly 5 weeks. We also see a higher defect rate. So unhealthy code has 15 times more defects, which directly impacts customer satisfaction and creates unplanned work. And we're also wasting some time here because 23 to 42% of developer time is lost due to technical debt. And this means in a team of 10, this would be like 2 to 4 full-time people just dealing with this poor architecture, right? And we're also having some kind of unpredictability here because now the longest task takes 9 times longer in these poor code bases, right? Which makes project planning kind of impossible because you never know if a simple task takes 2 hours or 2 weeks. So we can avoid these costs here by, like, for example, following an architectural pattern or implementing an architectural pattern like clean architecture with MVVM, which prevents these problems by design. So now let's see how clean architecture provides a solution to these documented problems here. So, well, we just identified these problems, right? Here's the solution, which is clean architecture by Robert C. Martin, or you may know him as Uncle Bob. And you could say it's kind of the gold standard for maintainable software that directly addresses every problem we just discussed. So for one, what we get when implementing or following clean architecture is a framework independence. So you see, your core business logic doesn't depend on React or databases or external APIs for basically implementation details, right? This means your business rules become the stable center while the technology changes around it. And if you take a look at the clean architecture diagram you see on the left here, this is Uncle Bob's original diagram. So you see we have 4 concentric circles here representing different layers of software. And the further we go on in this diagram here, the higher level the software becomes, or the more abstract, right? And the more we move outward, the more concrete these implementation or these layers become. And you also notice these inward pointing arrows here, right? So this is the dependency rule or dependency inversion principle, and we're going to talk about this in a bit. But for now, let's speak about the different layers here. Let's start with the innermost layer you see here, this yellow circle. This is the entities layer. And these are pure business objects, like, for example, later on our to-do entities. And this layer contains, for example, validation rules and business logic, but it knows nothing about databases or React, right? So it knows nothing about implementation details. And what we have in this layer here are enterprise-wide business rules that could, for example, also be used in different applications. So that's a benefit, a real benefit when implementing clean architecture. So the next layer around that is the use cases layer. And here we have application-specific business rules that orchestrate operations, like, for example, later on creating a to-do or getting a list of all to-dos, something like this. And they coordinate between the entities and the external systems through interfaces here. And what we have here is pure business logic with no mentions of, like, for example, React hooks or database queries. So the next layer around this, the green circle you see here, this is the interface adapters layer. And here we have controllers, presenters, and gateways that translate between the clean business layer and the messy real world. And this is also where our view models from MVVM later on will fit perfectly, as you will see. In this layer, we also have our repository implementations, which are fulfilling the interface defined by the business layer, so use cases and entities. And the outermost layer, this blue circle you see here, this is the frameworks and drivers layer. Here we have our React components, database connections, and like, for example, later on in our example, local storage for data persistence, right? So basically all the implementation details that can be swept out. And in this layer, for example, as mentioned, we have our React components, right? They know about our views models, so in the interface adapters layer, right? But not our business logic directly, right? And as mentioned, these inward pointing arrows, right? This is the dependency inversion principle. And this basically means that our dependencies can only point inward. And here's the problem with this. So our use cases, right? They need some kind of storage to persist our to-dos later on, for example, right? But they can't depend on local storage directly, for example, because that's a different layer, right? The outermost layer. And the solution to this is that our use cases depend on interfaces. So in our concrete example, the I2Do repository interface, and not concrete implementation, right? So now let's say you want to use Postgres, for example, instead of local storage. Well, in this case, you simply need to write a new implementation and change the injection, and your business logic stays unchanged. And well, with clean architecture, we're also getting a better testability and swappability. So for example, you could swap React for Vue, right, without changing your business logic, or you could switch MongoDB to Postgres without touching use cases. And when it comes to testing, you simply need to mock interfaces here for your unit test. And there's, for example, no database needed for this. So now let's see how clean architecture directly addresses each of these 8 problems we just talked about. So on the slide here in this table, you see how clean architecture directly solves every problem we just identified. And this isn't just any theory here. These are concrete solutions to expensive problems, right? So code duplications, for example, are solved through the reusable business logic in our use cases. And in general, clean architecture also promotes creating reusable components, right? And this helps us prevent these code duplications. Tight coupling is broken through dependency inversion, right? This dependency inversion principle we talked about. So our business logic, for example, never depends on React. And scalability is achieved through these module layers that expand easily. Also, testing is simplified with these isolated and mockable components, right? And these isolated layers. And well, when it comes to maintainability and migration, well, this clear separation we get with this architecture here means that changes don't ripple through the whole system here, right? And we are also achieving a framework independence here, which enables technology switches. So for example, we could swap React for Vue while our business logic stays unchanged. So you see, each problem has a direct architectural solution here. And those 23 to 42% of wasted developer hours now become productive time again. We are also seeing a faster time to market response with this predictable architecture here. And it's a future-proof investment that adapts to changing requirements. So, clean architecture gives us the foundation. But how do we handle complex UI state management cleanly? And how do we keep our React components testable and maintainable? Well, that's where MVVM comes in as kind of the perfect complementary pattern for the presentation here. So clean architecture provides the structure, right? And MVVM completes the picture for, like, for example, React development. So, yeah, before diving into implementation, let's first understand how MVVM fits into the broader architectural picture here and why it's kind of the perfect complement to clean architecture. So let's first talk about the MV pattern family. You see, the MV patterns share a fundamental goal, which is improving maintainability and testability through separation of concerns. And what they all have in common is the M, the model, and this handles data and business logic, and the V for view, and this handles UI rendering. And the mediator, so this asterisk you see on the slide here, and this varies by patterns. So in MVC, for example, we have the controller, so model view controller. In MVP, we have the presenter, model view presenter. And in MVVM, we have the view model, so model view, view model. Now, why is MVVM a good complement to clean architecture? Well, this is because MVVM takes the separation the furthest, right, by using data binding mechanisms. So unlike MVC or MVP, the view model has no direct reference to the view, which ensures a complete decoupling between UI and business logic. And this aligns perfectly with the clean architecture principles. So if you take a look at the diagram on the bottom left here, you see this diagram shows how the MVVM components map to the clean architecture layers. You see, the model spans both entities and use cases, the use cases layer, right? Handling domain objects and business operations. The view model serves as an interface adapter, transforming data between the core business logic and the UI, and the view is limited to the frameworks and drivers layer. So let's talk about the different components of MVVM, and let's start with the model. So the model contains our business logic, and as mentioned, it maps to clean architectures, entities, and use cases, right? And this includes domain objects like, for example, our to-do entity, as well as business operations like, for example, creating a to-do or getting a list of all to-dos or a specific to-do, right? And it's completely framework independent. Then next we have our view model, and this is our presentation logic bridge. We're going to implement this as a custom React hook just in a bit. But this is where our use cases are called to perform business operations. So the view model also coordinates between models and views, right? And it also contains some presentation logic, like, for example, loading states or form validation or data formatting. And then we have our view, which handles the UI rendering and it also captures user input. And these are pure React functional components, as you will see in a bit, written in JSX. So the views don't contain any business logic here. They just display data, right, and forward user actions to our view models. And this creates kind of the perfect harmony here, because clean architecture provides the foundation, right, and MVVM provides the presentation guidance. And this creates clear boundaries from domain logic to UI rendering with enhanced testability and framework independence. So now let's see the complete result of combining these two powerful architectural approaches. So we've seen how clean architecture and MVVM work individually. And together they create something powerful like, for example, React applications. Because, as mentioned, it's kind of the perfect combination, right? So clean architecture gives us the overall system structure, you could say the foundation, and MVVM fills the gap by providing specific guidance for the presentation layer. And together they create a complete architectural approach from domain entities to React components. What we get with these two patterns are, for one, clear boundaries. So every developer knows exactly where code belongs, right? So our business rules, for example, live in our use cases, the presentation logic in our view models, and UI rendering in our views. So there's no more guessing where or inconsistent placement here. And we also get an enhanced testability and independence. So because we can test each component in isolation, so we simply need to mock interfaces here, right, and test the logic. Our view models, for example, have no UI dependencies, and our use cases have no framework dependencies, right? And the business logic investment you're doing here by, like when implementing clean architecture, setting up your entities and use cases layer, right? This pays dividends as technology evolves, right? Because it stays unchanged by technology changes. And with this, we get a scalable architecture and better productivity. Because this architecture grows with complexity instead of fighting it. So clear patterns mean less time debating architecture, right? And more time solving business problems. And also, new team members become productive quickly because they, well, can just follow these patterns here. And, well, those expensive problems we identified at the beginning, now they become solutions, right? So 124% slow development becomes faster and predictable delivery. 15 times more bugs becomes robust and tested components. And those 23 to 42% of wasted time becomes focused and productive development. So, well, the combination works and the benefits are clear, but how does this translate to actual React code here? So let's see these concepts in action by building a real to-do application here that demonstrates every principle. So from clean architecture layers to MVVM view models to dependency injection. So, yeah, let's dive into implementation. But before we start, I want to set expectations up front right? Because this level of architecture is kind of overkill for something like a to-do application. You see, you'd never build something this complex for such simple functionality in production, right? But it's perfect for learning, right? Because it's simple enough to understand while demonstrating every architectural pattern we just discussed. So on the bottom right here, you see our wireframes. And these are our 3 main views that handle the complete workflow in our application. So on the left, you see this is our list view to display a list of all to-dos with some actions like, you can't really see this, but there is a little trash icon at the end of each line here. And in the center, we have our create view for adding new to-dos with a title and description. And on the right here, you see this is our details view for editing existing to-dos. And this gives us a complete CRUD workflow while keeping the UI simple and focused. So, as mentioned, clean architecture, kind of overkill for a to-do application, right? But it becomes valuable with complex business logic, like handling multiple user types or frequent requirement changes. And you will see an example for a more complex use case just in a bit. So you can think of this here as kind of your training ground, right? So you learn the patterns here and you apply them where they make business sense. So what you'll see, well, you see real dependency injection with Obelix. This is our dependency injection framework we're going to use for this. MVVM implemented with React hooks and functional components, and a complete data flow from our React components to, in our case, local storage. And also every clean architecture layer and working TypeScript code, connecting these 3 views here, right? So now let's see how these components map to clean architecture layers and understand the data flow of our application. So on the left here, you see the dependency flow diagram. And you notice how these dependencies flow inward, right? Because if you take a look at the top in the frameworks and drivers layer there, these red boxes, here we have our React views, and they depend on our view models, which are sitting in the layer right below the interface adapters layer, right? So the yellow boxes you see here. Our view models call our use cases right below the green box. And the use cases work with entities. In the entities layer, the blue box right at the bottom here. And this maintains the dependency rule or dependency inversion principle we've discussed earlier, right? Because you notice these arrows show these inward dependency flow, right? So let's talk about a data flow example in our application. Let's say a user wants to create a new to-do. So what they do first is they're filling in a form in our view, right? Then the view calls an appropriate view model method. And the view model, for example, could validate the input here, and it calls the create to-do use case. And the use case then could process some business rules here and calls our repository, which then will persist to local local storage in our case, right? And if everything was successful, the user will be back on the list view. So let's talk about benefits here. So you see, each layer has a single responsibility, right? Which makes the code maintainable and testable. For example, you can test your business logic without React, right? You could swap local storage, for example, for a real database, or change the UI framework without touching your business rules. So now let's see how we structure the projects files and set up dependency injection to make this architecture work in practice. So, and well, this is where architectural theory meets practical organization, right? So this folder structure you see on the upper left here, it directly reflects clean architecture layers, right? So no more guesswork about where code belongs here. So let's talk about the structure here. So you see each folder name clearly indicates its architectural role, right? So you see we have a domain folder here, and this spans the entities in this model subfolder you see here, and the use cases, well, in the use cases folder, right? Because both are pure business logic, right? And this is where we place them in the domain folder. The interface adapters are split between the adapter folder you see here, where our repositories live, and the presenter folder, where our view models live. And our React components in the frameworks and drivers layer, they sit in a subfolder of the presenter folder. You can't see here. It's simply called pages. And well, this is where our React components live. And the code snippet on the right here, this is our Avalex DI container, right? As mentioned, we use Avalex here as our lightweight dependency injection framework. And this single file here defines how every component gets its dependencies, right? You see in here, we are registering our repository layer, right? All our CRUD use cases and the free view models for our free views. They are all registered as functions here. And if you take a look at the usual example, so right at the bottom here, you see this, the iResolve to-do list view model, right? And in this case, Avalex automatically creates the view model with all required dependencies injected. So this means our components don't create dependencies themselves, right? this container here provides the improved version of control. And this as function here, you see, we're calling here, this is a utility function provided by Ovilix. And what we're doing here is we're passing in a function, and Ovilix in this case knows, okay, this is a function I get here, I need to inject these functions dependencies via the function parameters, right? You will see this in a bit. So, yeah, benefits for clean architecture here. You see, in tests, we could simply replace the registrations here, right, with mocks to test each layer independently. And now let's say you want to switch from local storage to an API, for example. Well, in this case, we only need to change one line in our repository registration here inside this container, right? And of course, provides a new implementation for this. And also, all dependencies are configured in one place here, right? Which helps us maintaining this dependency rule or dependency inversion principle through this container here. So, this container makes our React components incredibly simple. So now let's see how clean the Vue components become when they focus purely on rendering. And this is what a clean architecture view looks like in React. So you notice how simple and focused it is, right? This component has only one job, which is rendering the UI and forwarding events. And you also see the dependency injection action here. So you, again, right below the function header, you see this DI resolve to-do list view model, right? This connects the view to all business logic through this view model. So there are no constructor parameters here, no prop drilling. We just resolve what we need. So what this view does versus doesn't do. So you see this view renders our UI, right? It also handles some user navigation with React Router. You can see this when taking a look at the return statement. We have this list component here, right? And this has this on-item click property. And what this is called when a user clicks on like a to-do in our list view, right? We're calling this navigate function, which right below the function header is provided by the use navigate hook, and this comes from React Router basically. And we're also simply forwarding user interactions here to our view model, right? If we stay at the list component here, you see this on item delete property, right? In this case, when this is called when a user clicks on the trash icon. We're simply calling this show delete dialog, right? And this is provided by our view model. So, but in this view here, there's no state management, right? All state comes from our view model. There's no business logic here. We're just forwarding events, right? And no data fetching because our view model handles this for us. And, well, this is the V in MVVM, right? The view. So purely declarative UI that observes our view model state. And this two-way data binding, we implement this through these destructured properties of our view model and the event handlers, right? As mentioned, we're simply forwarding like user events here to our view model. So, yeah, some clean architecture benefits here. You see, this view is very easy to test, right? We simply need to mock our view model here and verify that the UI renders as expected. And also, UI changes don't affect our business logic. And this view model, so the view model could, like for example, also work with Vue, Angular, or any other framework, right? Because it has no idea that this is React here. So, and coming back to code quality here, well, you already noticed how readable this is, right? So no complex logic, no nested state here, no side effects. And also, as mentioned, each event handler is a simple function call to our view model. So this simple view here works because all complexity is handled by the view model. So now let's see how the view model manages state and coordinates with business logic. So, and this is where MVVM really shines. So because this view model here manages all presentation logic while staying completely independent of React components. So let's talk about the dependency injection here. You see, our dependencies are injected through the function parameters, right? You can see this up here, right? This get to do use case and delete to do use case. And this, as mentioned, is handled by Ovilix, right? So you remember this as function, utility function we were using, right? And well, like this, we get our get to do use case and delete to do use case. And the view model, it's important to note the view model depends on abstractions here. So use case interfaces, right? And not concrete implementations. And this follows clean architecture's dependency inversion principle. And we also have some state and use case orchestration here. So you see, we have two pieces of local state right below the function header. You see the to-do to delete and the to-dos, right? And then we're also having two methods here. So get to-dos, you can see this here. This calls our get to-do use case to get, well, a list of all of our to-dos. And once we have that, we're updating our state here. So you see this set to-dos, right? And this delete to-do method here, this calls our delete to-do use case. And once the to-do is deleted, again, we're updating our state here. So this means this view model here bridges pure business logic with React state, right? And let's talk about presentation logic. You see, we also have this sort by ID method here, which is responsible for sorting our to-dos by ID, right? And so this basically handles UI-specific sorting, right? That doesn't belong in the business layer. And we're also having some dialog management here. And with this, I mean, if we go back to the view, you see if this on item delete callback is called, right? We're calling this show delete dialog. And if we take a look at the view model here, you see in this case, we're simply updating this to do to delete state, right? And once this is set, you see this delete to do dialog will be rendered. So that the user can make sure he really wanted to delete this to do, right? So you see, like mentioned, this is the dialog management, right? And we're also having some data transformation here because we're not simply returning our to-dos here. Before we return them, we're sorting them with the help of the sort by ID method, right? So, as mentioned, dialog management here, data transformation in. This is happening here and not in the view and not in the business logic, right? So, let's talk about benefits here. This view model, it's very easy to test, right? We just need to mock our use cases, and there's no React rendering needed, for example. And it's also framework independent. Well, of course, you see, for our local state, we are using the use state hook by React, right? But we could also simply remove these React imports and add a different state management, right? While our business logic stays the same. And this means this view model here could also work with Vue, Angular, or any other framework. And, well, that's the VM in MVVM, right? The view model. So it knows about our domain, so our use cases, and it also provides data to our view. And if you take a look at the return statement here, it returns exactly what our views need, right? So some data, our to-dos, some actions like the delete to-do, and some state, so to delete, right? And this creates a clear contract between view model and view. So this view model here calls our use cases to perform business operations, right? So now let's see how we put all these layers together in our complete implementation. So a lot of stuff here on the slide, but I will guide you through it. So let me first show you both a simple and complex use case. So first, our learning example, so a to-do from our to-do application, a use case from our to-do application, right? And well, then what use cases look like when they handle real business complexity. So let's start with our simple use case, our get to do use case. You can see this on the upper left here. As you can see, once we call this execute method here, we are simply forwarding this call to our repository in this case, right? So it's essentially a CRUD wrapper. That's perfect for learning to understand how to set up use cases, where to place them, how to call them. But, well, in production, you'd call the repository directly for such simple operations, right? So you see, the architectural investment when implementing clean architecture in MVVM, well, it pays off when you have genuine business complexity, like on the right here, our more complex use case example, the process orders use case. And if you take a look at this in here, we have some customer validation, right? We have inventory checks, pricing calculation, payment processing, and a multi-repository coordination here. And this demonstrates what use cases are really designed for, which is orchestrating complex workflows with business rules. And on the bottom left here, you see our repository implemented in the interface adapter, right? And as you can see, this repository implements an interface, right? So the I-to-do repository interface, which is defined in the domain layer, so our use cases and entities. And use cases only depend on that interface and not this concrete implementation here. So, and this, well, this follows the dependency inversion principle, right? So our use cases never know that in our case here we're using local storage. So it could be, for example, Postgres or MongoDB or REST API, right? So you see, each step in this complex use case here is clearly defined and testable, right, in isolation. So you see, we simply need to mock repositories here, for example, to test specific business operations. And the repository, on the bottom left, right, this repository handles data access only, so no business logic here. And this means we could, for example, easily switch the storage implementation here by changing our DI registration, right? So we've now seen every layer in action, so from React components to local storage. This complete implementation here demonstrates how clean architecture and MVVM creates maintainable and testable applications. So we've completed our journey from clean architecture theory to working React code, right? Now let's recap what we've accomplished here and what it means. So what we've demonstrated here. You see, every clean architecture layer has real and working TypeScript code, right? And the MVVM pattern is implemented with React hooks and functional components, right? And also the dependency injection we're using here creates a loose coupling in our application. And we also saw a complete data flow from user interaction to, in our case, local storage. So let's talk about the architectural foundation here. You see, these patterns, clean architecture, MVVM, right? They create maintainable and testable applications that scale with complexity rather than fighting it. And also this clear separation of concerns here makes our code easier to understand and modify. And the dependency rule, or dependency inversion principle, it ensures that our business logic, for example, remains framework independent. And coming back to being completely honest, right? So you see, this level of architecture, again, is a complete overkill for such a simple application as a to-do app, right? So because, again, you'd never build something this complex for such basic functionality in production. But these patterns become invaluable with real business complexity, like already teased in our more complex use case example, right? So when, for example, handling multiple user types or external integrations or dealing with complex workflows. So we only saw one view and one view model from our to-do application, right? So the complete implementation is available on our GitHub. You see this link down here. Well, you could also simply Google Space Team's GitHub, right? And when accessing our GitHub, this will be one of the first repositories you see there. And you can use this as your starting point for your own project, so with all concepts in working TypeScript code. So the implementation now is complete. Let's examine the results and see how these architectural choices transform these expensive problems we identified into practical solutions. So, if you think back to the beginning of this presentation, well, we identified some critical problems that cost teams time, money, and sometimes even sanity, right? So, tight coupling, for example, that makes every change a risk assessment. Testing complexity that slows down development cycles, and scalability challenges that, well, create bottlenecks as applications grow, and also reduce maintainability that increases long-term costs, right? These weren't just any theoretical issues. These are the real issues you face daily, right? We then introduced clean architecture with MVVM as a complementary pattern. And with this, we get a clear separation of concerns because now each component has one responsibility, right? So our view models handle the presentation logic, our use cases contain business rules, and the repositories manage data access. So there's no more guessing where logic belongs here. And we also get clear boundaries. So because these layer boundaries here create predictable change points. So let's say you want to modify the UI, right? In this case, you only touch the view layer. Or let's say your business rules change. Well, only your use cases need updating in this case. And we also talked about this dependency inversion principle, right? And this means that our components depend on extractions and not implementations, right? So this means we could, for example, switch local storage to a REST API by changing just this one line in our DI container and providing the new implementation, of course. And it's good for structured growth because this architecture here grows with your application instead of fighting it. So if you add a new feature, you basically need to add a new use case and a view model, right? And you see the structure completely supports this. And, well, this is what we achieved, right? So not just working code, but a foundation for maintainable React applications. You see, every architectural decision here directly addresses the problems we started with, right? But this level of architecture isn't right for every project, like, for example, our to-do application. So let's talk about when these patterns make sense and when they don't. So you see, clean architecture and MVVM, it's kind of a good choice when dealing with complex logic, right? It's already teased with our complex use case example. So applications with complex workflows, validation rules, business processes that span multiple entities, for example. Could also be a good choice when working with multiple teams. So, for example, when different teams work on like UI, business logic, and data access, right? The clear boundaries we get with this architecture prevent conflicts. And it's also a good choice for long-lived applications. So, well, systems that will be maintained and extended for years, right? The upfront investment we're paying when implementing clean architecture and MVVM, it pays off later. And it's also good when like dealing with external integrations, right? So when you need to switch between different APIs, for example, or databases or services without rewriting your business logic. And might also be a good choice when dealing with frequent requirement changes. So when your business rules change often across different domains, for example, these isolated layers we get with clean architecture minimize the impact. But it's kind of an overkill for simple CRUD applications, for example, like our to-do application, right? So basic data entry forms don't justify this complexity. Simpler patterns work better here. And also not a good choice necessarily for prototypes and MVPs. So when speed to market is crucial, architectural purity usually takes a backseat, right? And it might also be not a good choice when working with small teams that communicate constantly. They may not need these rigid boundaries here. And it's also not a good choice for short-term projects. So projects with fixed requirements and short lifespans, they don't benefit from long-time maintainability here. And of course, not necessarily a good choice for learning projects. Because if you're learning React, right, you should focus on React concepts first and then at architectural complexity later. So you should always be honest about the cost-benefit analysis here. With clean, or when implementing clean architecture and MVVM, you get more files, more abstractions, and more concepts to understand, right? But what you get in return is a predictable structure, testable code, and flexible implementations. So always start simple and evolve thoughtfully. You see, you don't have to choose all or nothing here. You could start with a basic separation of concerns, like extracting business logic from your components, right? Then you could introduce the repository pattern when you need data source flexibility, for example, and introduce full clean architecture when the complexity justifies it, right? So always let business needs drive your architectural decisions and not architectural ideals. So understanding when to use these patterns is as important as knowing how to implement them, right? So now let's wrap up with the key takeaways from our journey here. So yeah, what we've learned. As mentioned, we've started with these expensive problems, right? Tight coupling, testing complexity, scalability challenges. We then explored clean architecture as a solution here with its 4 layers with clear boundaries and responsibilities, right? And we saw how MVVM enhances the presentation layer with views, view models, and model coordination. And then we built a complete React application demonstrating every concept in working TypeScript code, right? So the key takeaways here are, as already mentioned, start simple and evolve thoughtfully. So don't start with full clean architecture for every project. Begin with a basic separation of concerns and add complexity when business needs justify it. And focus on actual problems here. So apply these patterns to solve problems you're generally facing, right? So like tight coupling or hard to test code or when dealing with frequent technology changes. And not just any theoretical issues here. And also invest wisely. So the upfront complexity when implementing these patterns, right? It pays dividends for long-lived and complex applications. Like with multiple teams, right? When working with multiple teams and when dealing with frequent requirement changes, for example. And of course, you can use our template, right, from our GitHub repository. So this gives you a working foundation to build upon, right? So some final thoughts. Well, you see, building maintainable software doesn't require complex frameworks, right? It requires thoughtful architecture. So you don't need the latest trendy framework here or the most complex patterns. What you need are thoughtful decisions about how to structure your code. Clean architecture and MVVM give you that structure. So a foundation that supports growth instead of constraining it. So, you see, these patterns are practical solutions to expensive problems, right? Every pattern we've discussed directly addresses the issues that cost teams time and money. And, well, the to-do example was simple, right? But the principles scale to enterprise complexity. So you can take these patterns back to your current projects and start with extracting business logic from your React components, right? Introduce a repository pattern when you need data source flexibility, for example, and build toward full clean architecture when your application complexity justifies it. And well, with this, thank you very much for joining me on this journey from theory to practice.